Hello, welcome to Mini Math Lessons with Karen. And today I'm just focusing on one lesson, so this will be a relatively quick video. It's sort of an application or assessment or concluding type of activity for proportional reasoning. The reason being, students have to create their own scale, their own proportion, and then use that. So you could get many different answers, but we'll explain that once I look at the activity. Using Classpad, free dynamic math software, pretty much does whatever you need. What I love about it most is its multiple representations. I can do pictures, graphing, data, statistical plots, text, graphs, equations, all in one place without having to go to different tools. So that's a really nice thing. So here's the landing page for it. Start exploring, totally free to do. The activity I'm sharing is in the links below, also free. If you want to save anything or start creating accounts and activities on your own, then I would create a free account. It's totally free, and so that makes it really nice. And there's a lot of things in the library as well that you could just use right away or modify. So suggest you create an account. Let me go into the activity. So this is a proportional reasoning one. And this shows you some nice things about Classpad right here. So here's the text stickies, and we call all of this stickies because they can be moved and put where you want them. So you can basically arrange your paper however you want. Whenever I make these activities, I really like to kind of color coordinate. So you'll notice my banner matches all the directions. So anytime I give a direction, it's kind of color coded with the banner. And then I always put yellow stickies where students are going to respond. So they kind of get in the habit of whenever they see a yellow sticky, they realize they're supposed to be responding in it. So here's this activity, and notice this is using the ability for Classpad to insert images. So I've inserted an image, and I kind of set it so that this guy's hands are at the 0. So his finger right here, his hands are technically on the x-axis, and he's juggling. So this is a chef juggling peppers, which, yes, that does happen. My husband is can juggle pretty much anything when he's cooking. Eggs are the worst. So the first thing they have to do, and this is where the application, so it's proportional reasoning, but instead of giving them the scale, they have to create it themselves. So it's really kind of thinking about what does that mean. So the first thing they're asked to do is find some reference points here, and they can do that. So we're in a graphing sticky here, and this little image right here lists some plot points. So they can just pull up a point thing, and maybe we want to change the color of the point so that they stand out a bit more here. And so it says, put some reference points on here so that you can figure out how tall or how far it is, the distance from the chef's shoulders to his head, the top of his head. So there's a lot of decision that has to come in here. So I'm just going to make 2 points real quick. And it doesn't matter what I initially set them up as, because I'm going to be moving them. I'm just going to use 2 points because we just want distance, right? So we just need 2 points to figure out distance. So they're supposed to figure out, okay, where should I put these 2 points so that I can calculate the distance or figure out a good height for this chef. So let's say I want, I'm thinking that it makes sense. I'm just thinking my own, kind of here from the tip, and then where is, I don't want to use the hat, but maybe I do, but I'm going to use the top of his forehead, right? So those are my 2 points. And so then I have to figure out what is the distance, but they want the real world distance. And so then how do you know how far that is? Because on the graph, obviously, that's not how far it is. So how are they going to do that? So they could, maybe look up average distance between someone's shoulder and the top of their head. They could measure with their classmates and get an average. So however they decide to do it, they all will come up with this. Well, we think a good reference point is the top of the shoulder all the way at the tip to the top of the forehead, and that should be 11 inches or 12, whatever they think it is. And so they come up with their reasoning and their conclusion. So we've decided that a typical height between shoulder and top of the head for a man is, 11 inches. Let's just say that. So they write their reasoning here. Then based on that, so think about it, you have students that all might have different answers depending on where they decided to place their reference points. How then do we determine, so here it is on the graph, which obviously is not 11 inches, so how do I determine what each one of these grids on my y-axis represents. If this is supposed to be scaled, proportional, what's the ratio, what's the graph to the real world? And they get to come up with their own determination of what each one of these, what's the scale that's needed for the y-axis. So notice there's no numbers on here except for the 0 origin. They get to come up with their own scale. And so again, depending on how they're looking at this, you're going to have all your students with different answers. I would suggest working in groups. So they come up with their own ratio, right? Their own scale. And then based on that, then they come back down. Notice same image, slightly different, larger, and we've numbered the peppers. And they're going to then place these points somewhere on the peppers and come up with what's the distance using this scale that they developed up above of each pepper to the chef's hand. So then the question is, which hand are they using? And what are they talking about by distance? What finger? What is it? This hand or that hand? Those types of things. Or are we going to just say distance from this horizon, this x-axis? So all these decisions they have to come up with, but they're applying the scale they developed to find the distance. And then it becomes a really interesting conversation comparing all of these. And then even placing the points with the peppers becomes, and this is the nice thing about Classpad, you've created these points, but you can move them and notice how they're dynamically changing in the table as well. And that really helps. So it's about consistency. Do we want it in the same position for each pepper? Is it the stem that we're going to always put it on wherever the stem is? That's what matters. Or is it the highest point away from the top, the highest vertical point, or the horizontal? So things like that all come into play. And so it's a really interesting application of proportional reasoning.